differentiate this, I get x over y. Now f, y, y. Remember, I'm going to write this as x, y to negative 1. Or just write x, and I know that 1 over y prime is negative 1 over y squared. Same thing from here, same thing from here. So this is negative x over y squared. And now I differentiate y, fy, with respect to x. When I differentiate this with respect to x, I get 1 over y. Good pick. Is this okay? Okay, can we look at a word problem now? Okay, so let's look at 41 on page 567. Lincolnville Sporting Goods. Okay, so here let me share my screen. I'm reading it from the book, but it's better to read it from here. Okay, so we have Lincolnville Sporting Goods has the following production function for a certain product. Okay, so that is P of x comma y, which is 2400 times x to 2 over 5 times y to 3 over 5. P is the number of units produced. P, number of units produced. X, units of labor. Number of units of labor. Good. Y, units of capital. Perfect. Find the number of units produced with 32 units of labor and 1,024 units of capital. How do we do this? Part A.
Plug it in.
Of course. Absolutely. Perfect. So that's part A is really nothing. So they said 32 units of labor and 1024. So I have 2400 times 32 raised to 2 over 5 times 1024 raised to 3/5. Okay. I'm going to share my screen. Where is my calculator? And I have... Now Kimmy is going to be very happy because I cannot put these variables of functions of two variables in the calculator. Ha! I have no choice but plug in step by step. She's going to be very happy. So 2 divided by 5 and multiplied by 1024, and the power is 3/5. Yes, you can put 0.6, of course. 3 over 5. Okay. So number of units produced, 614,400 units. Okay, perfect. Back to the book. Find the marginal productivities. Okay. Marginal productivities. Same thing with marginal productivity that we had for one variable. But this time will be px and py, because this is a function with two variables. So first I will differentiate with respect to x, keeping y fixed, and then so this is with respect to the number of units of labor, and this is with respect to the number of units of capital. Okay, when we keep the other variable fixed. Okay, so when I differentiate this with respect to x, these two are constants. So here I differentiate this. I bring down 2/5. So 2400 times 2/5 times x to 2/5 minus 1, negative 3/5, and this is fixed. Yes, I have to multiply 2400 by 2 and divide by 5. So I'm just going to leave the room there because I will not have enough room. So I'm going to continue with px. So what do I get when I multiply? So this is 4800 divided by 5. Always correct my numbers. I got 960. Let me know if it's wrong. So y to 3/5 over x to 3/5. Yes, we like to write it like this, only because these two powers are the same. Otherwise, I cannot. So this is the marginal productivity, the derivative with respect to x, the partial derivative with respect to x, when the number of units of capital is considered fixed. Okay, now let's determine py. So I differentiate the same function, but this time I keep x fixed. So these are done. I copy them. Bring down 3/5. Oh, subtract 1 from 3/5, negative 2/5. So now I multiply 2400 by 3 and divide by 5. And I got 1440. Correct my numbers, please, anytime. And I have x to 2/5 over y to 2/5. So I'm going to do the same thing. 2/5 x over y. And this answers part B of the question. Any questions for me before we continue? Any questions here? Anyone? Any questions? Okay, then we can move on to part 3. Oh, okay, I see. I'm sharing my screen. Thank you. Okay. So we did. Evaluate the marginal productivities when x is 32 and y is, so the same numbers they gave us initially. 32 and 1024. Okay, fine. So for the point 32, 1024, we will determine px and we will determine py. Okay, so here for the first one, I'm going to write it here anyway. Y over x, so 1024 over 32, everything to 3/5 or 0.6. And this one is 1440, but this time is 32 over 1024, and 2/5 will be 0.4. Okay, I can do this without a calculator. Okay, so 960, and in parentheses, 0.24 divided by 32. And the power 0.6. It may take it without parentheses, but you know me already. And then the other one, 1440, and in parentheses 32 divided by 1024. And the power is 0.4. 360. So the first one was 7680, and this one was 360. Measurement unit. This is a derivative. It is a partial derivative, but it is a derivative. Can anyone come up with the rate of change, the measurement unit for this?
Is it unit per
Yes.
capital?
Excellent, excellent. Yes. So this one is with respect to labor. Very good. Units. So number of units produced with respect to labor when capital is fixed. And the other one, excellent, is the number of units. It's with respect to units of capital when the number of units of labor is fixed. Very good. So since I don't have room here, I'm going to write on the next page. So Px equals 7680 units produced per units of labor with respect to units of labor when units of capital are fixed. But you know what I mean? This is good enough. I mean, I just want to make sure that we understand what this is. But units produced over units of labor with respect to units of labor. Yes. And the other one is Py equals 360. And it's still units produced, but this time with respect to units of capital when units of labor are fixed. So units produced with respect to units of capital, and so on and so forth when units of labor are fixed. You can say this, and I would agree. But units over units kind of doesn't have any measurement unit, but this is specifically the correct measurement unit, I would say. Okay. Now, one last thing that we need to talk about is how to find max min for these functions. And that's the final step, the last topic. And this is the last section, which is 6.3. Max min for functions of several variables. We're going to talk about two variables. Okay. Good. So there is something called the d-test. So this is what we are going to talk about. The idea is the same. If we have a function like f of x equals x cubed plus 2x, which is a function of one variable, how do I find the max min? Well, I find f prime, I find critical numbers, and I study the sign of the derivative. So this was the idea for functions of one variable. Pretty much similar here. But this time we have to find two variables, partial derivatives. So step number one, we find fx and we find fy. What am I trying to do? I'm trying to find max min for a function of two variables. And I'm comparing it to the steps here. We have the function, we find the derivative, we set it equal to 0 or undefined. We find critical numbers, study the sign. Here we have several steps. We don't have only one variable. We don't only have one f prime. We have two, because we are talking about two variables. We have fx and fy. In step number 2, we solve the system, exactly the same idea. Fx equals 0, fy equals 0. Instead of having a critical number like x equals 2, we will have from here a point. Points. Point or points, x comma y. And then after we solve, in step 3, we conduct d-test. And then we conclude. And I will get to the d-test together with you in a minute. Okay? So by comparison, I have to find fx, fy. I have to create a system with these two. Again, set them equal to 0 like before, but we have 2. Here we get just one or several, but just x equals, but here we get a point or points from solving the system. And then for each point, we conduct the test for each point. For each point found in step 2. And then we will conclude max, min, or none of the above. Or the test is not applicable, which is possible. Okay, so let's start with an example and work our way through and see how the d-test works and how we find max, min. Okay, I'm going to share my screen and go to page 576. 576. Okay, so let's start with a function. Let's pick a function. Find the relative max or min value. Let's pick a function from 1 through 14 and work on it.
Number 6.
Number 6. F of x comma y equals x to the third plus y to the third minus 6xy. Very good. So we want to find max min or relative max min or local max min. Same thing. So in our first step, we have to find fx. When differentiate with respect to x, everything else is a constant. When I differentiate with respect to x, I get 3x squared. Nothing. When I differentiate with respect to x, I get negative 6y. Then I find fy. Same thing, 3y squared. When I differentiate with respect to y, I get negative 6x. So this is our first step. We determined the partial derivatives.